All right, so we're going to talk about quiz B for about 20 minutes. Then I'll give you a few minutes to study before we get started for our quiz on quiz C for chapter 6. So in this problem, again, similar to what we did yesterday, we have local school board members deciding to review class size information to determine if their budgets are correct. So it gives you a couple of things here in this table. It gives you Y bar, which is the mean. What is the average number of students in a class?
33.39.
Very good. So that's the average number of students in the class. Now, in part A, it says, notice that the third quartile and the maximum class sizes are the same. How could that be? How could you have your quartile 3 and the maximum the same? We've never seen that before. I do have another one. Guys, that's why I gave you the folder, right? All right then. Any ideas on how you could have quartile 3 and the maximum are the same? Yes, Pablo. Do they have to be outliers? They could be, right? And we could determine if they're outliers. Absolutely. All right? They could be. But I think what most students think is that the quartiles and the maximums and the minimums, there's always just one of them. But, bless you, this just means that there are how many classes that have class size of 40 students? More than one. Now, 40 is the number of students in there. There could be 40. But there are so many classes that have 40 students that it is your third quartile and it's your maximum. Okay? So that's what I'm going to write for number 1. I would say that the class size of 40 students is the largest in this school, and there are many of them, so it causes it to be the same. So the class size of 40 students is the largest class size out there, but there's so many classes that have 40 students that we have the quartile 3 and the maximum are both 40. Now let's think about this. When we talked about this with box plots, right? If this is quartile 3 and this is the maximum, what percentage of the data is between the third quartile and the maximum? Any ideas? What? Yes, if this is quartile 3 and this is the maximum, what percentage of the data values are between those two? 25% is right, Chris. So that means 25% of these class sizes are what class size? Are 40. 20. Remember, the quartile splits it up into always 25%? So there's actually 5 of them. This is quartile 0, but we never say that. We say it's the minimum. This is quartile 1. The median, we always say median, but what quartile is the median? Quartile 2, then quartile 3, then the maximum. So it's 25%, 25%, 25%, 25%.
But, okay, so
That's 100%.
Oh, so whenever it's like maybe like moved to this way, you know, said,
Well, the percentages don't change, right? Are you talking about like, yeah, if I move this way?
Yeah.
So from quartile 3, yeah, you have 25% of the data values are this way, 75% of them are to the other way. Is that what your brain's thinking? I just want you to think the percentages are the same. The number of data values could be different. Okay? Like, think about it. For this box plot, our quartile 3 and our maximum are the same. So there won't be an upper piece because it's the end of the box. But that just means 25% of the class sizes are 40. All right?
So it's like, what is it? What is that called?
The whisker.
The whisker. If the whisker is long, does the percent change?
Percent is the same. That just means your minimum is farther away. Good question. So like if the box was here and the whisker was here, but this whisker went further, It's the same percentage that of the data values that are here and here, but this one obviously is going further to the left, so it's lower values.
So, meaning that there's not that many numbers, the 25%, the quarter 0, quarter 1, there's space between all of them.
Yes, there's space. The data values will be the same percentage of data values. I want you to think of it like that. You'll have the same percentage of data values. They might be spread out more. Is that what you're right? Yeah, okay. All right, let's look at part B. The school district declares that classes with enrollments fewer than 20 students are too small. Like our class would be considered too small. Would you consider a class of 20 students to be small? What are they thinking you should do here? Find out if 20 is, and how do we do that? Very good, Giuseppe, below the lower fence. And Gilberto's brain already is thinking about it too. What's the IQR?
9.
Not 9. 11, very good. It is 11. How did you get that, Giuseppe? 40 minus 29. Then we take that number, write this down, Bashir, and do 1.5 times that. What's 1.5 times 11?
16.5.
Very good, Alyssa. So we're going to find our lower fence and our upper fence by doing quartile 1 minus 16.5 and quartile 3 plus 16.5. So what is our lower fence? 29 minus 16.5. 12.5. I'll circle that. So if we're asking ourselves, is 20 unusually small? Giuseppe's thought is 20 lower than the lower fence? Is 20 lower? I'm sorry, probably yes.
You want to subtract 2,
Yeah, so to find the lower fence, you do quartile 1 minus that number. So the upper fence is quartile 3 plus the number. So back to what we were saying. Is 20 lower than 12.5? No. So is 20 unusual? No. They might say it's too small, but it's not unusual. It's not an outlier. Now, we don't even need to calculate the upper fence, because if the quartile 3 and the maximum are the same, will we have an outlier on the other side? No, because the idea is if you have 40 is quartile 3, you know you're going to add something to it. But if your max is also 40, there's no way it could be an outlier. All right, which is interesting. So we have no outliers in this distribution. Everybody okay? Say it again? Yeah, sure. So the upper fence would be quartile 3, 40 plus 16.5, which is 56.5. But if quartile 3 and the maximum are the same, you won't have an outlier because you're adding something to quartile 3 to get the fence. How, if I add a number to that, will I ever have the same number greater than that fence? I won't. You can't because it's the same. All right, so we don't have any outliers. Yeah.
So if the minimum was like 11, it would be.
Yes, if there was a class size out there that was 11, then that would be an outlier because it's below the lower fence. All right. Okay, let's try C and D. Scroll down just a little bit, so a little bit more room. C and D. For part B, it is not unusually small because it is not below our lower fence. It's not an outlier. You're welcome. If you show me the work, you can just put it's not an outlier. Like if I can see your work. Part C. They've decided that they're going to set their budget based on the enrollment of the students. That makes sense? They plan to spend $12 per class. So whether the class size is 12, or whatever we have in here, or 40, they're going to absolutely spend $12. But then they're going to add on 75 cents per student. So let's see what that does to our numbers. What are we going to say is the median class budget for office supplies? Well, we know we definitely have to have what? $12, right? So it'd be $12 plus
No, not, oh, yeah.
plus 75 cents times what is the median class size? 33. Okay? 36, 75. Bless you. Can anyone confirm Gilberto's number of 3675? Yeah. Don't confirm it until you have it. Excellent. Now, if you were not here yesterday, here's what gets tricky. Now it's asking about the IQR. Well, we just calculated the IQR in part B. What was the IQR? 11. All right? So most students are going to do what when they answer this? They're going to do 12 plus 75 cents times 11. What's that? Okay. They're going to do the same thing but plug in 11. And why will they be wrong? Why will that number be wrong? Because it's a measure of spread. So our measures of spread change by adding or subtracting a number to all the data values. It's not. IQR is a measure of spread. It's unaffected by adding 12 to everything. Think of it like this, Bashir. We had 40 minus 29 is 11 for our IQR. What's 40 plus 12? 52. What's 29 plus 12? 41. What's 52 minus 41? Still 11. So measures of spread are unchanged by adding and subtracting numbers. But they are changed by what? The multiplication. So I'm going to use a different color here to show you that we're going to multiply just 75 cents times the IQR of 11. So what's 75 cents times 11? $8.25? All right. Any questions on that? Yes, for sure. Yeah, measures of spread, like IQR and standard deviation, are only affected by multiplying and dividing. Standard deviation. Okay? Measures of center, like median and mean, are affected by everything. Adding, subtracting, multiplying, dividing. What's up? Okay. Can anyone tell Dino why we didn't add 12 to the orange? That's right. Okay, very good. Let's go to part D. Part D wants you to do the same thing, but to the mean and standard deviation. So again, the mean is going to be just like what we did with black there. So it'll be $12 plus 75 cents times, what was the average class size? They did 33.39 is the average, Y bar. Up at the top, that Y bar is the average. And then to find the standard deviation, you're going to do just 75 cents times 5.66. Very good. Okay, and that will give you your answers. Anyone have an answer for the mean? So 3704? Okay. What about for the... You got 25, what? Did you add 12? Okay, what about standard deviation? 425? Okay. I heard you go better. Oh, for sure. Get that on the recording. All right. Any questions on how to do this? Because you're going to do this for a grade on the quiz. If you have a question, let me know. I guess I wrote $2 signs. Oops. I mean, I'm probably not going to take off, but I should write the units, right? I mean, those are units. Say it again.
2 lines and 1.
2 lines? Oh, 1 line's fine. I don't care.
So like the formula, basic formula, like that, both sides.
Okay.
And then like supply like other things, how do you know?
Are you talking about for part C and D? Okay, so the idea is, in my brain, I'm thinking if it's a measure of center, everything they want me to do happens to it. So like median and mean, everything. That'll be the addition and the multiplying. For measures of spread like IQR and standard deviation, that's just going to be the multiplying part.
You said mean and
So no, median and mean were together because those are measures of center. And then IQR and standard deviation are together. Those are measures of spread. I know earlier, Dino, a couple weeks ago, I made you link mean and standard deviation. Those are linked, but in this way, we have different relationships because we're talking about scaling and shifting and rescaling data, which affects measures of center and spread differently. Well, they should give you a table with all of the original numbers, like it says the median. You'll notice there's the median, the IQR, there's the IQR, mean, there's the mean, standard deviation, there's the standard deviation. Basically, they're telling what this happening, Dino, is they're taking statistics about class sizes and taking that and using this formula of 1275 plus 75 cents per student for a class and finding out how much money they're budgeting per class for supplies like paper, pencils, pens, things like that.
so you only add the addition to the mean and mean.
Correct. Any other questions about number one?
Oh, yeah. So, would it always be like that? Why is
So what was the question?
for the one, for A, right?
Oh, for A. It might be. If it is, you'll just mention that there are enough of the maximum, whatever it is, right? There are enough data values of that so that 25% of the data is that number.
So that's just saying there's no outliers.
We calculated there's no outliers for part B. We don't need to mention outliers in part A.
Where do we get 33?
Oh, just from the table.
Wait, where did we get 16.5?
16.5. Is that when I did the 1.5 times 11?
Yes.
Yeah, 1.5 times the IQR.
Where did we get 1.5?
That's the number you're always going to use. You might go to college and the professor might tell you, hey, use 2. The idea is both are accepted.
You always times that by the IQR
Uh-huh.
to get like.
That number you're going to use to find fences. You're going to add that number to quartile 3, subtract it from quartile 1 to get fences.
Right.
Yeah. Those.
For A, would you like to apply to the minimum and there's 25?
Yes, it would. You would say 25% of the data, the lower 25% of the data is all the same number. Good question.
So just the maximum, just say the higher 25%.
Is all the same number. All right, let's go to number 2. Number 2, we have the postmaster in a post office believes that a normal model is useful in projecting the number of letters which will be mailed during a day. The mean is 20,000. So I'm going to put a normal model. Do you guys remember the notation I use? Mu and sigma. So that's going to be 20,000. And what is the standard deviation?
250.
250. Okay, how many standard deviations above and below do I care about? Very good, Alyssa. 3. 1, 2, 3. 1, 2, 3. The idea here is that 68, 95, 99.7, that rule means that you're expecting all of your data to be within 3 above and 3 below. Standard deviations, that is. So what's 20,000 plus 250? Very good. Add another 250. And finally, I know I'm having to write small, I'm sorry. Sorry if you can't read it. I think the numbers on the quiz are smaller, so it'll be easier to write it. Okay? So that's what I'll be checking for number 2, making sure you have these numbers correct. And I'll be checking for this notation.
Okay, so you, when you look to the right, you have.
Correct. Correct. And so what I tried to do in your brain yesterday was I asked you, what is the z-score for 20,250 letters? It's 1. Very good. Go back to y. Because it's 1 what over? 1 what? Very good. 1 standard deviation over. It's 250 letters to the right. That's 1 standard deviation. So the z-score for that one would be 1. And then what's the z-score for this one? 2 and 3, and then -1. And so the z-score for the mean is 0. No, I'm just trying to link this in your brain. All right, so you get the idea that if you are finding z-scores and you get a z-score of -8, what are you going to say? That's unusual or unlikely. It could happen, absolutely, but it's very unlikely to have a z-score past 3 or -3. That's what I'm trying to help your brain understand. All right, let's go to number 3, and then we'll be done. It was just to write down the model. Oh, yeah. Okay. Well, that was on the recording. Light bulbs. We've got 2 light bulbs. We have a standard white light bulb and a soft white light bulb. Now, both bulbs at a competition lasted 750 hours before dying. That's a long time. They just waited. Yep, they watched it. Their eyes went a little crazy. Which bulb was the more impressive bulb? How can we compare them if they are different types of bulbs? Finding the z-scores. So let's do the standard and soft. This is real data. This is where we use y minus y bar over s. Standard deviation, very good. So z equals, how long did the standard white bulb last? How long did the standard white light bulb that we have last? 750 minus, now here's the question you guys answered, what is the average lifespan for a standard white light bulb? Doesn't it say at the bottom here, it says at a local competition, both bulbs lasted 750 hours? So that's where I got the 750. Don't be mean to the local scientists. Minus 675 over the standard deviation of 50. For the soft white, again, also lasted 750, but there's a different mean. What is the average lifespan for that bulb? 700 with the standard deviation of 35. So this will allow us to compare the two, even though they're from different bulbs. So what's that? 75 over 50. And we have 50 over 35. Ooh, 1.4. 443. So, which bulb was more impressive when it lasted 750 hours? The standard, because it's bigger than that one. This 750 is farther away from that mean than this 750 is from that mean. Okay? So that would be a sentence I'm looking for. I know I'm not writing down, but a sentence I'm looking for on the quiz. The standard white light bulb was better because it had a higher z-score. All right. Go ahead and clear your desks. No notes. What is it, calculator?